All right, good morning class. Welcome back to another round of scoring. This is lesson 69 and 70. To get started, I'm going to show you something that a friend of mine had an opinion on the coronavirus. It's not a friend of mine, and maybe a lot of you have seen this already. It's not a friend of mine, and it's not true, but it's funny.
Because of coronavirus, you are going to be quarantined, but you have a choice. Do you A, quarantine with your wife and child, or B?
All right, like I said, maybe his opinion, not mine. Enough of that. Lesson 69 and 70, there was a couple of questions people had, and a lot of you got them solved already, and that's good. Starting with 69, number 1. Trapezoid FHJL has midsegment GK. Find the length of FL. The length of FL is 40 feet. There's a couple ways you can do it, but if you just think about it a little bit, 16 HJ plus FL added together, and then half of that. And so you can take 28 times 2, that's 56, and then subtract 16 off of that will leave you with 40. You can actually do the actual formula and say that GK equals 1/2 of FL plus whatever the other one, HJ, and then fill that in. So you know that GK is 28. 28 equals 1/2 of 16 plus some number, HJ, and you solve for HJ, get rid of the 1/2, take this times 2, so 56 equals 16 plus HJ, so 56 minus 16 equals 40, HJ equals 40. That's the quick method. Number 7. What is the sine of a 30-degree angle if the hypotenuse is 10? And you should get simplified to be 1/2. It'd be 5/10, because the sine with a hypotenuse of 10, the sine of 30 degrees up here, if this is 30 degrees, then this is 60, so it's a 30, 60, 90. That means this is 5 down here. That's what was, that's the piece of information that was missing that you have to find out with knowing it's a 30, 60, 90. So 5/10. And then you can leave this triangle here, and then they say the cosine of a 60, which would be down here, and then this changes to 100. Well, that simply means this changes to 50. Whoops, wrong side. This changes to 50. So 50 over 100 again, 5/10 or 1/2. So the answer for 7, the sine of a 30-degree angle is 1/2. The cosine of a 60-degree angle is 1/2. Number 8. Is there more fluid in the rectangular container or in the cylindrical can? And I wish they would have changed this question a little bit and maybe made the can just slightly bigger, but because it looks obvious, it looks like the rectangular container is bigger, and it is. So if you just guess that, then you're correct, but hopefully you actually did the math and find the volume of both of those, and they're fairly close actually. There would be 80 cubic inches in the rectangular cylinder, in the rectangular can, and 78.5 in the cylinder. So not as much difference as what you would think, and if they would have just made that can slightly bigger, then it would have more. But anyway, I hope you did the math on that, find the volume of both of those, and the answer is rectangular container. All right, number 14, find the length of the sides of kite RSTU, round to the nearest tenth, please. So if you use the Pythagorean theorem for both of those, and the reason you can use the Pythagorean theorem is because you know that the diagonals of a kite are perpendicular, so those central angles in there are 90-degree angles. So you have one triangle with one leg of 6, the other leg of 10, and the hypotenuse, that TU, is going to be 11.7 to the nearest tenth. So TU is 11.7, UR is 11.7, and RS and ST, the top ones, are 8.5, both. So 8.5 for the top two and 11.7 for the bottom two, Pythagorean theorem. Number 16, how many vertices does a polyhedron with 6 faces and 12 edges have? If you go back to lesson 49, Euler's formula, you will get that it has 8 vertices. 8 is the answer for 16. Number 19, in an isosceles trapezoid as given there, find UW, find the length of one diagonal. If Tx is 23 and V x is 20.7. Simply add those two together and you get 51.7 because the diagonals in an isosceles triangle, in an isosceles trapezoid, the diagonals in an isosceles trapezoid are congruent. 51.7. Number 25, find the measures of A, B, and C, angle A, B, and C in trapezoid ABCD. They give you one angle, that is a trapezoid, but it's also an isosceles trapezoid because they tell you that with those two congruent marks, which means that the angles are congruent. The base angles are congruent, so angle B is 93, just like angle C, and angle A and D are 87. 180 minus 93 equals 87. Because remember, if you go down this way, these two are parallel. So if you go down this way, make a turn, come back this way and make a turn, you end up parallel from what you started, then your total of those two turns would be 180. So that's how you get 87 for A and D. Number 26, we looked at this yesterday. Find the sine of B, the cosine of B, and the tangent of B in the triangle. And they're not actually looking for the lengths of the sides. They're simply just getting the practice again with the ratio. Oscar had a hold on Arthur. So the sine is opposite over hypotenuse, which means it's 8 over 17. The cosine is 15 over 17. And tangent is 8 over 15. That is what you should have for 26. 28. Do you need to know the side lengths of a 30, 60, 90 triangle to find the sine or cosine of its angles? And the answer is no. The reason is because of problem 26, like we just looked at. The sine, the cosine, and tangent of angles are simply the ratio of side lengths. So technically, you don't need to know the actual side lengths. You'll just have a ratio. You could argue that one probably. But 28, really, you would say no, you don't need to know the side lengths because sine and cosine is a ratio of the side lengths, not the side lengths themselves. All right, going to number 70, lesson 70 that is. Lesson 70, number 1, find the measure of angle P and the measure of angle R in this kite. The measure of angle P is 111 degrees. The measure of angle R is 111 degrees. You could do this a couple ways. The way I would do it is draw a line through a vertical line from Q to S, and that cuts 100 in half, and it cuts 38 in half. So you have 50 and 18 or 19 or whatever that is, bad math here. 38 divided by 2, 19. So you have 19 and 50, and then you know that a triangle has to have 180 degrees. So if you have 50 up here, that's on this side, 50 on this triangle, and you draw a line here, and you have, 19 here, then you got to have whatever's left here to make 180 degrees for this triangle. So 50 up here, 19 down here, means 111 here, 111 there. And there's maybe multiple ways you could get that. All right, number 2. What's the volume of a regular hexagonal pyramid with a height of 10 and a base side length of 7? Round the answer to the nearest cubic foot. The first thing you need to do is find the area of the base for this. And you, again, look at the apothem. So finding the apothem of a hexagon with a side base length of 7. Can you see up here? Hexagon, not a hexagon. Try again. With 7 here, you go like this, and you know this is 7, so now you have a triangle down here. This is the apothem, that's what you're trying to find, and this becomes 3.5, so if you take the triangle out of the drawing, you get 7 over here, 3.5 here. Remember 30, 60, 90. The reason you know it's 30, 60, 90 is because this is a hexagon, so all these are 60-degree angles in here. 60, 60, 60. Cut this one in half, you get 30. So there's 30 up here, there's 60 down here, and there's 90 down here, of course. 1, 2, square root of 3. That's the ratio. So this answer is 3.5 square root 3. Now remember, we talked about not letting a decimal in there. In this case you can, because you're actually going to just keep, you could put that in your calculator and find a long answer and get it. Or if you don't like the decimal like we talked about earlier, you would go 7 square root of 3 over 2. This and this is the same thing. It doesn't matter which one you use, but that is the apothem, that is the height there. Then you take the formula for the volume of a pyramid, which is 1/3 of the I'm sorry, you're looking for the volume of the base. The volume of the base first is 1/2 of apothem times perimeter, and that gives you a volume. So the formula for the base, you got to find the area of the base first, and that is 1/2 times apothem times perimeter. The perimeter is simply 7 times 6, so 42. So the formula would be 1/2 of the apothem, which we said was 3.5 square root 3 times 42. Just do all that and you get 127 point something. 127.31 approximately. That's the area of the base. That's this area. Now take your formula for finding the volume of a pyramid, which is 1/3 volume equals 1/3 of the area of the base times the height. And they give you the height, I think height is 10, and the area of the base, I said volume of the base, but volume is 1/3 of area of the base times the height. So 127.31 times the height times 1/3, and you get 424. That is rounded to the nearest cubic foot, 424 cubic feet for number 2. All right, number 8. Complete the following statement. In a 45, 45, 90-degree triangle, the blank and blank are equal. The sine and cosine are equal. If you do the math there, the sine and cosine are equal in a 45, 45, 90-degree triangle. The reason is because you have equal legs here. You've got if this is 1, this is 1, and this is square root 2, or whatever it is, these two are always equal. So sine, cosine, both are dealing with opposite and adjacent. Or they're not dealing with opposite and adjacent, but they're using opposite and adjacent. They're both over the hypotenuse, and the opposite and adjacent are equal. I said that wrong. But anyway, sine, cosine are equal for number 8. All right. Number 11, what is the lateral area of a rectangular, what is the lateral area of a regular octagonal pyramid with base side lengths of 4 and a slant height of 10? You're looking for lateral area, use the formula, you get 160 inches. That's again from lesson 70. Number 16. 16 we discussed yesterday, and hopefully everyone got it. Again, probability is what are you aiming for? That's on top, and what is the total choices? So the total choices are on the bottom. The total choices is that whole area. That area, if you add that together, you get 6 plus 7 plus 7 plus 4, that's 24, and you get 2 plus 6 plus 5, that's 14. So it has a height of 14 and a width or whatever of 24. 24 times 14 is 336. That's your total possible area is 336 square inches. Find the blue, total the two blues together. 6 times 2 is 12, and 5 times 4 is 20. 12 plus 20 is 32. Your probability of getting in the blue is 32 over 336. Now, you can simplify that to whatever, 2 over 21, or just convert it to a decimal or fraction, decimal or percentage. If you go to percentage, it's about 9.5% roughly. All right, 19. What is the surface area of a regular hexagonal pyramid with a slant height of 8, base side length of 2? Round your answer to the nearest centimeter. It is 58 centimeters, cubic centimeters. 58 square centimeters, or centimeters squared, whichever order you prefer. 58 for number 19. All right, number 20. Fernando said that ABC was translated to form the image A prime, B prime, C prime. Raquel said it had to be rotated, not translated. Who is correct? If you just look at those two, it's in your book there. Triangle ABC and the other one, you hopefully will see that it was rotated to the right to get the order. It was not just translated, it was not flipped, had to be rotated. So Fernando is correct. No, Raquel is correct. Whoever. All right, 23. 23, when the Great Pyramid of Giza was first built, the side length of its square base was 231, and so on and so on. What is its approximate lateral area? Round your answer to the nearest 100 square meters, not hundredth, but 100. And this problem, if you have a problem with this problem, look back on example 4 of lesson 70. It's exactly that same thing. You got to find you got to do like a cross section in the middle there, and you find half of the total base. Since the total base is 231, you got to find half of that. That's the distance in. And the slant height, you use a slant height to find or you use the height to find the slant height. A squared plus b squared equals c squared. Just look at example 4 on lesson 7. It's exactly that. Your answer then should be 86,400 square meters. Number 23 is 86,400. Number 24, find the measures of F, G, J. We did one like this before, so G is going to be 97, and J is 97. I'm sorry, J is 97, and F and G are 83 each. 27. Use a calculator to find the length of MN. I think we did this yesterday as well. The length of MN is 25.04. That is rounded to the nearest hundredth. Again, you look at that problem and you say, what am I working with? I'm working with I'm basing my home base is at angle M, because that's my 56 degrees. And I have a side length of ML of 14, and I need to know MN, which is a hypotenuse. So you're dealing with adjacent and hypotenuse. Oscar had a hold, so you're using the cosine. Cosine of 56 degrees is adjacent over hypotenuse. So 14 over that other one, and then rearrange that. 25.04 is the answer for 27. For 30, Stevens make 2 square pyramids. First pyramid has a base of 10, height is 20. The second has twice the height and only half the base length. What's the volume of the second pyramid? So they try to make it complicated. Use the dimensions from the first one and do what they say, half and twice accordingly, and you get 333 cubic centimeters. That is rounded to the nearest cubic centimeter, 333. All right, that's it. Hopefully that cleared things up. If you have more questions, ask your fellow students or ask me when you're scoring or after you're scoring, and if you still have questions. Thanks.